Hello friends, welcome to this video on the topic Educational Data Analytics. This is Shomir Roy, Professor of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Kolkata. The entire lesson on Educational Data Analytics has been covered in two videos. The present one is the second part. In the first video, we discussed the subtopics learning associations, classification, regression, role of educational data analytics. In the present video, we will discuss behavior detection, data synchronization, feature engineering, feature generation and feature selection for behavior detection, along with some case studies also. As mentioned in the first video, after successful completion of the entire lesson, you will be able to explain the basic concepts and components of educational data analytics and initiate activities to apply the techniques of educational data analytics in teaching learning. Behavior detection. In educational scenario, behavior detection is required to provide personalized learning to the students. In order to understand the students' engagement in learning activities, the teacher has to monitor the students' behavior. Traditionally, this used to be achieved through classroom interaction. However, in recent past, machine learning techniques have been used to analyze classroom videos. The purpose is to assess the students' attention related processes through visible indicators of engagement or disengagement in learning. P. Goldberg and others have reported machine vision approach for behavior detection that was based on gaze, head pose and facial expression of the students captured on camera. This table shows the exemplary behavior indicators used by them. Researchers have developed automatic behavior measurement systems to record the students' activities in classroom. They installed many Kinect devices in the classroom to collect typical gestures such as sitting, raised hand, standing, sleeping, whispering and so on. Experimental results show that such systems are useful in measuring the students' behavior and analyzing the students' engagement in classroom teaching learning. Now we come to data synchronization. After behavioral detection, we come to data synchronization. It is a process of establishing and maintaining consistency of data among several devices as well as updating changes automatically among them. Data synchronization has become a critical issue in the era of big data and cloud computing. This is a continuous process rather than a one-time task. There are many challenges to data synchronization such as complexity of data formats, real timeliness, security, quality of data, etc. Complexity of data formats is due to the fact that the same data may exist in different forms. Such data should be transformed from one format to another. Another crucial issue is real timeliness. Quite often, systems giving access to users in real time need to update the data in real time. Such real time data synchronization is a non-trivial task. There are two kinds of data, unordered and ordered. Typical methods of unordered data synchronization are wholesale transfer, timestamp synchronization, and mathematical synchronization. Synchronization of unordered data. In wholesale transfer, all data are transferred to one host for local comparison. Timestamp synchronization consists of making the changes in data with timestamp. In mathematical synchronization, data are treated as mathematical objects and synchronization as a mathematical process. In case of ordered data, we assume that the data differs by a number of edits such as character insertion, deletion, modification, and so on. The data synchronization then is a process of reducing the edit difference or edit distance between the data to an ideal distance of 0. A typical example of is the file system based synchronization where the data are ordered. File based data synchronization. Common file based data synchronization tools are file synchronization, version control, distributed file system, mirroring, and so on. Among these, version control and file synchronization tools can deal with modification to multiple copies of the file. File synchronization is an automatic process to make the file transfer in home backup more efficient and less error prone. When many users try to modify a file simultaneously, version control tools are required to assure data synchronization. In distributed file systems, multiple versions of a file are to be synchronized. Here, the devices storing the files are usually connected, but in some situation disconnected operations followed by reconciliation are permitted. The term mirror implies an exact copy. They are used to provide multiple sources of the same information. Error handling. Another issue of data synchronization is error handling. This is indispensable for fault tolerant distributed systems. Error handling starts with replication, that is making multiple copies of the data up to date as changes are made. In case of loss or corruption of data, we have to retrieve the data from a reliable copy. Now we come to feature engineering. Machine learning algorithms need some input data to produce outputs. However, the success of the learning algorithm largely depends on the quality of data being fed. A lot of time and effort are devoted to preparation of data for machine learning. According to a survey in Forbes, data scientists spend 80% of their time on data preparation. It has been found that the data scientists spend 3% of time in building training set, 60% in cleaning and organizing data, 19% time is spent in collecting data, 9% in mining data for pattern, 4% in refining algorithms, and rest 5% in other miscellaneous activities. This report shows the importance of feature engineering in data science. Feature engineering can be described as the process of creating features on the basis of domain knowledge of the data suitable for machine learning algorithms. It is the process of transforming raw data into features that better represent the underlying problem to the predictive model, resulting in improved model accuracy or on unseen data. Feature engineering has two goals: creating the input data set which is compatible with the requirements of the machine learning algorithm and improving the performance of machine learning models. Professionals opine that feature engineering is absolutely vital to machine learning success. Much of the success of machine learning is actually success in engineering features that a learner can understand. In feature engineering, usually the following steps are undertaken: brainstorm the features, create new features, check the effectiveness of the features in the model, and then iterate. The success of all machine learning techniques depend on the way we present the data. This is why machine learning practitioners spend most of their efforts in feature engineering. In short, feature engineering transforms the input into something the machine learning algorithm is able to understand. Nowadays, automated feature engineering is fast gaining importance as an emerging area of research and practice. Finally, we briefly discuss the interesting topic of feature generation and feature selection for behavior detection. Detection and assessing students' behavior within an interactive learning environment is crucial to personalized learning. This is a fertile area of application of data mining and machine learning techniques. Feature generation and feature selection for behavior detection are important steps of such process. M. Mavrikis and others have reported a case study on the use of educational data mining (EDM) techniques to assess the quality of students' interaction in terms of learning and subsequently to predict whether they can answer a given question without asking for help. Predicting whether a learner requires assistance or not in a certain teaching learning situation is a non-trivial task. They employed a Bayesian network based machine learning method on data sets collected through the application of the interactive learning environment called WALIS over 3 years, that is from 2003 to 2005. The resultant Bayesian model obtained through feature generation and feature selection for behavior detection was integrated in the ILE system. The output was utilized by a diagnostic agent. The diagnostic agent was considered by feedback mechanism for the sake of adapting to actions. Well, my friends, with this we conclude the lesson on educational data analytics. I hope you have enjoyed the 2 videos on this topic and found it useful for your purpose. Please go through the e-content for further details and some more case studies. Thanks a lot and see you again in the next video.